All right, so here's what we're going to do. We're going to take each of these problems and we're going to use the guess method to solve for what it's asking us to solve for. Then we're going to sketch. It's not a detailed graph, it's a sketch. I want to see what the position graph looks like and what the velocity graph looks like. So let's jump right in. So for the guess method, in addition to listing out our givens and our unknowns and picking an equation and solving, I want us to, and I've said this a lot, I want us to box our givens. Whoops, sorry about that. I want us to circle our unknowns, or the question in this case. So, a toy car has been given an initial velocity of 8 meters per second. It speeds up at a rate of 2 meters per second squared over a distance of 9 meters. What's the new velocity? So, givens are going to be a little bit easy, right? So it right away tells us that the initial velocity is 8 meters per second. Then it says it speeds up at a rate of 2 meters per second squared. This is going to be the acceleration, and two things tell me that. One, speeds up in rate. Rate of speeding up by definition is acceleration. The other thing is the units on that 2 meters per second squared. Meters per second squared means acceleration. So the acceleration is 2 meters per second squared. And that takes place over a distance of 9 meters. And what I want to know, my unknown here, is the new final velocity of the car. So in order to do this, we got to go find an equation that has all four of these things in it and nothing else. Since there's no time here, the only equation that fits is v squared is equal to v initial squared plus 2a delta x. And I want the final velocity. So we're going to plug our numbers in. Final velocity squared is equal to 8 squared plus 2 times the acceleration of 2 times the delta x of 9 meters. So if we calculate everything out, that gives me 64 plus 2 times 9, when you put it in your calculator, is 36. I'm going to continue that over here. Sorry. Velocity squared is equal to 64 plus 36. So the velocity squared ends up being 100. If I want to solve for the velocity, I've got to square root both sides. So that velocity comes out to be the square root of 100, or 10 meters per second. That's our final speed. So that's the guess method for this, but I also want to draw a position versus time graph. So we're going to do position versus time here, velocity versus time here. Now, the velocity versus time graph is going to be the easiest. I have an initial velocity of 8 and a final velocity of 10. So I start off with a positive velocity and I end with a positive velocity. So we have a line with positive slope, starting positive, ending positive. For position, we're going to start off with a positive slope and we're going to end with a positive slope. And so it just kind of curves up a little bit. We're moving forward, speeding up, moving forward, speeding up, and we have a positive acceleration. So we know that that's going to be concave up. We're looking for smiley faces anytime we have positive acceleration. Let's look at the second one. A bus has an initial velocity of 12 meters per second. If it accelerates at 8 meters per second squared for 4 seconds, how far will the bus have traveled? So our givens are the initial velocity, 12 meters per second, the acceleration of 8 meters per second squared, and the time is 4 seconds. My unknown is my displacement. How far will it go? So I need to, I need to pick an equation that has all four of those things in it. Well, my only winner is is delta x is equal to v initial times time plus 1/2 acceleration times time squared. I've got all of those things, so delta x is equal to the initial velocity 12 times the time of 4 plus 1/2 times the acceleration times the time squared. Well, this is just math that we could put into our calculator. 12 times 4 is 48 plus 64. So my delta x comes out to be 112 meters. So now we want to graph that. Well, I know that we're going to start off for velocity versus time with a positive initial velocity. So my intercept needs to be positive, and then I have a positive acceleration. That's the way that we're going to go. Now, on position versus time, doesn't matter where we start, but we'll start at 0. We start off with a positive slope, and it gets more and more and more positive. So our line is going to curve upward, which again is good. We have a positive acceleration, so we need to have a smiley face type graph to go along with that positive acceleration. Three, more of the same. Bus has an initial velocity of 12 meters per second. If it slows at a rate of negative 8 meters per second squared for 2 seconds, how far will the bus have traveled? So my givens are the initial velocity of 12 meters per second, slows at a rate of 8 meters per second squared. Again, it's the rate of slowing, so I know that that's going to be acceleration, and those units, meters per second squared, tell me that. So my acceleration is negative 8 meters per second squared, and the time is 2 seconds. And my unknown is how far. So in order to solve this, I need to find an equation that has all 4 of those things in it. So the equation that we have is delta x is equal to initial velocity times time plus 1/2 acceleration times time squared. So my delta x is equal to 12 times 2 plus 1/2 times negative 8 times 2 squared. I'm going to go ahead and continue that down here. There's no real algebra, we just have to plug this into the calculator. 12 times 2 is 24, plus, and here's what happens. I have a negative sign here, so this next term is going to be negative. So that delta x comes out to be 24 minus 16, 8 meters. I still have a positive delta x. So, for our graphs, let's start off with velocity versus time. I know I start off with a positive initial velocity. That's positive, so we're up here, but my acceleration is negative. Now, a velocity versus time graph. Negative acceleration means that we move, our velocity gets more negative. I have a negative slope, and that's worth writing down again. Negative acceleration is negative slope on velocity versus time graphs. So we have to keep that in mind. Now, when we do the position versus time graph, pardon me. All right, we're going to move forward, and this is a really important part. My delta x is positive 8 meters. So if I start here, I'm going to have to end somewhere up there because I'm moving forward. And that's what's important about this the whole time. We can see this on the velocity graph, right? So if we look at this, what we see here is positive velocity the whole time. I have a positive velocity the entire time, which means we are moving forward. I'm moving forward the entire time because I have a positive velocity. This area is a positive area. I am moving forward. That's really important when we're looking at our position. Again, supported by that positive 8. So we're going to move forward, but our acceleration is negative, and my velocity starts off positive, so the slope here is going to start off positive, and then my velocity gets closer to 0, so it's going to end closer to 0. That's a curved line, but it's a line that's curving down, and that makes sense. I have a negative acceleration, so I'm going to have a downward curvature or a frowny face. Let's move on to this last one. A race car accelerates from rest to a velocity of 48 meters per second in 400 meters. What's the acceleration of the race car? So the initial velocity is 0 because we're accelerating from rest. My final velocity is 48 meters per second. That's my final speed. And that takes place over a distance of 400 meters. Those are all my givens. And my unknown is the acceleration. So if we box all this up, what we see is v initial, v final, delta x, and acceleration. Looking through all of our equations, the one equation that goes with that is v squared is equal to, v final squared is equal to v initial squared plus 2a delta x. V initial is 0, we can make that go away. Let's plug in everything else. 48 squared is equal to 2 times the acceleration times 400 meters. So putting that into our calculator, 48 squared is 2,304 is equal to 2 times 400, it's 800 times the acceleration. So let me move that down here. 2,304 is equal to 800 times the acceleration. If we want to solve for the acceleration, we're going to divide both sides by 800. That crosses out, and my acceleration comes out to be 2.88 meters per second squared. See, no negative signs here, so that's going to be a positive acceleration. Now let's think through our graphs. We have velocity and time. And my velocity starts off at 0 and it goes to 48. So I have a positive slope here, which makes sense because I have a positive acceleration. Positive acceleration equals positive slope. Now, for position versus time, I'm going to start here and we're going to move forward. We're going 400 meters forward, so we're going up. Now, my velocity starts off at 0, so my slope has to start off at 0. My velocity ends up positive, so we're going to curve up, which again makes sense. We have a positive acceleration, so we need to have a positive curve or a smiley face for being concave up.